Hello. Today we're going to look at our next section. That would be Section 8, Perpendicular and Angle Bisectors. This is on page 23. So if you would go ahead and get that out, and if you need to pause the video until you get that, go ahead and do that. Okay, perpendicular and angle bisectors. This section really is just looking at rules and theorems surrounding these two ideas. And we've already talked about these two ideas a little bit, but today we're going to learn a couple rules that go with them. So the first set of rules are the perpendicular bisector theorem, and then the converse of perpendicular bisector theorem. So when we break down the word perpendicular and then the word bisector, remember, perpendicular forms a right angle, bisector cuts something in half. So let's break this theorem apart. It says here, if a point is on the perpendicular bisector of a segment. So when you look at this picture right here, this, the perpendicular bisector, first of all, is right here, perpendicular, and then these two marks mean it is bisecting. So it says here, if you have a point on this perpendicular bisector, then it is equidistant from the endpoints of the segment. So here would be my point. So if I have a point here that is on this perpendicular bisector, then that means that the distance from that point over to B and the distance from that point over to A are equal. So what our picture would end up looking like if I reconstructed it here, if I drew this segment and that perpendicular bisector, so I have a right angle, it's cutting that segment in half. So what it's saying is if you have a point on this perpendicular bisector, so I'm going to put a dot right here, this theorem says it's the same distance from either endpoint. So the distance from the dot over here is congruent from the distance from that dot over there. And actually, we can explain this with congruent triangles and CPC-TC, but this is a quicker way to get there. Okay, so if we have this scenario, then we can set these two sides equal to each other. So the converse is like the reverse. So the converse says if a point is equidistant from the endpoints of a segment, so look at this picture, the only thing you know is that this segment is congruent to the other segment. So if that's the only situation you have, then two things are true. It is on the perpendicular bisector of the segment. So these two items are true. So let me start out with that picture and then I'm going to draw on it. So you have a line like this and then you have a segment. So if you have a scenario where you have a point right here and it is the same distance from either endpoint. So once you see that these two things are true, I know I have a right angle. In fact, I have two right angles. And then I know this section is congruent to that section. So we're going to use these two ideas to set up problems, or set up equations, I should say. All right, so first example here. Find the length of MN. So when I look at this picture, I see a right angle, and then I see these two congruent marks. So that means this is the perpendicular bisector. So my theorem up here says if you have the perpendicular bisector, then these two segments are congruent, these two segments on the side. So I'm going to mark that here. I'm going to put a double mark on MN and a double mark on NL. So MN is equal to NL. And then what I'm thinking to myself, the reason is the perpendicular bisector theorem. So once I recognize that, if I'm trying to find the length of MN and I've marked them equal, it's going to be the same as the 2.6. So MN is equal to 2.6. So I have to have a reason for coming up with the answer for anything in geometry. My reasons are my theorems. Next example, find the length of BC. So pay attention to what you're given. I see 38 here and 38 here. Those two are congruent. And that's all I know. So when I look at the converse says if you're given equal distances here, then you know two things. You know a right angle and you know equal sides. So I know a couple things. I know that DA right here, DA is perpendicular to BC. So I'm going to put a mark there. And I know that BD is congruent to DC. So BD, segment BD is congruent to segment DC. So both of these are because of the converse of the perpendicular bisector theorem. Okay, now I can answer my question. Find the length of BC. Well, if BC is this whole thing, I also know that BD is 12, so BC is going to be equal to 24. So once you recognize all the different properties, then these problems are going to be pretty quick. All right, one more, and then I'm going to have you all do the next one. So find the length of TU. So when I look at this, TU, first of all, I see a right angle, and then I see congruent sides. So I can say that TU is equal to UV because of my first theorem, because of this perpendicular bisector theorem. So I'm going to say that TU is equal to UV, and the reason is the perpendicular bisector theorem. Okay, now when I look at it, these are both have x's in them. I can just set them equal to each other. So 3x plus 9 is equal to 7x minus 17. And now I'm ready to solve. So I'm going to take away 3x from both sides. So I have 9 equals 7 minus 3 is 4, so 4x minus 17. So plus 17 on both sides. So what is that? 17 and 9 would be 26 equals 4x. And so when I divide off my 26, I'm going to get a decimal. So let me see, what is that going to be? 26 divided by 4 is 6.5. And I need the length of TU. So TU is 3x plus 9. So I need to plug that in. So 3 times 6.5 plus 9. So 3 times 6.5 plus 9, I get 28.5. So TU is equal to 28.5. So go ahead and pause this. And then I want you to work these two out. And then when you come back, I'll have the solutions ready for you to look at. Okay, when I look at the fact that this is a perpendicular bisector, that means I have a right angle here, and then these two sides are congruent, which also makes these two congruent. So if EG is 14.6, then I also know DG is 14.6. So DG is 14.6. Okay, second one over here. If it's perpendicular bisector, again, I'm going to mark here, I'm going to mark the bisector, and then also these two sides are equal. So DE is 20.8, so that's the whole thing. And then DG is 36.4, and then EG is 36.4. So I need to find the length of EF. Well, since I've got the perpendicular bisector here, EF is just half of 20.8. So if I take 20.8 and divide by 2, I get 10.4. So I have EF is 10.4. Okay, let's move on to angle bisectors. Angle bisectors really have very similar ideas. We've got an angle bisector theorem and then a converse of angle bisector theorem. So we know what a bisector means. If it's an angle bisector, something got chopped in half. So this first one says here, if a point is on the bisector of an angle. So take a look at this picture. If this angle is being bisected, these two arcs are present. So point C is on the bisector. So if it's on the bisector, then it is equidistant from the sides of the angle. So this is true. AC is equal to BC. Now I'm going to draw the picture again because I need to talk about one part of it. So I'm going to draw myself an angle bisector. So those two angles are congruent, and here's my point. Now, in order to find the distance between a point and a line, we talked way back in Unit 1. The shortest distance from this point to either side of this angle would be forming a right angle with that line. So that's why when a segment is drawn, it forms a right angle. And when a segment is drawn, it forms a right angle because that's the shortest distance. So this theorem says if you have this scenario where you have an angle being bisected, then this dot is exactly the same length from either side of the angle. Okay? So the converse is true in that you have the equal distances. So the converse of the angle bisector theorem says if a point is on the interior of an angle, if a point in the interior of an angle is equidistant, so you know that this distance is the same, then it has to be on the bisector. So if your scenario looks like this, you have an angle. You happen to have this point here on the interior, and you know that it makes a right angle here and here, and it's the same distance. Well, then these angles have to be fixed. So in the end, you get the same idea. It just depends on which one you start with. So let's run through a few examples here. So find the length of BC. So when I look at this picture, I have here a angle and an angle right here. So that tells me that this is the angle bisector. So point C is on the angle bisector. So I know that BC is equal to DC. So I'm going to write here that BC is equal to DC. And my reason is this angle bisector theorem. So angle bisector theorem. So these are things you need to think about or you won't be able to solve these. So if those two are congruent, then that's also 7.2. So BC is 7.2. Okay, next one. Find the measure of EFH given that EFG is 50. So I want to find EFH. I want to find this one right here. I'm going to put a dot. Given that EFG, the whole thing is 50 degrees. Well, what I see on my picture is I see H, this point, is the same distance from either side. So the converse says if that's true, then it is on the bisector. So then I know that these angles are congruent. If the whole thing is 50, I want this half of it. So when I divide it by 2, I have my answer. So the measure of EFH is 25 degrees. Okay, next one, and then I'll have you finish this out with the last two. Find the measure of MKL. So MKL is right here, but I have variables. So when I look at this, I see equal distances. Therefore, M is on the bisector. If that's true, then these angles are congruent. So I can write this equation. 3a plus 20 equals 2a plus 26. And I can do that because this is showing the converse. So when I solve it, take away 2a. So that gives me a plus 20 is 26. And then take away 20. So I am getting A is equal to 6, but I need the measure of an angle. So MKL is 2A is this one right here. So I'm going to plug it in. So 2 times 6 plus 26. So that's 12 plus 26. So what is that? 38 degrees. Measure of MKL is 38 degrees. Okay, I want you to try the last two. So go ahead and pause it, and when you come back, I'll have the solutions ready. Okay, the first one here, the answer is 3.05. You needed to recognize that this angle here is congruent, and these are making right angles. Therefore, the angle bisector theorem says those are congruent. Second one, I have labeled everything in the picture. Because these are equidistant from the angle itself, therefore the converse says that these angles are also congruent. So I just doubled my 63. Okay, your homework, if you want to go ahead and take a look at Canvas, your homework will be out on Canvas.